Okay, so welcome to 10.1, which is an introduction to the circle. So a circle is essentially a set of all the points that are a given distance from the one point called the center. Okay, and that given distance is referred to as the radius. So in other words, it is a multitude of points, right? So these are all points. And each of these points are an equal distance away from the center. And the distance that we refer to these purple lines as is the radius. Okay, so that is how a circle is made. We essentially picture like a string attached to a pen and it just swinging around attached to that center right there. And each of it is creating those points that are equidistant away from the center. Okay, concentric circles are two circles that have the same center. So again, they have a different radii. So for example, this radius might be 2 inches, whereas this radius right here might be 3 inches. So they have a different radius, but they both are made from that center. So again, if I was to create another one, let's say with a 4-inch radius, I'd have to keep it 4 inches away the entire time, and that makes a concentric circle. When you throw a pebble into water, and it hits the water, it forms those ripples that are concentric circles around where the pebble hit the water. Two circles are congruent if they have congruent radii. Okay, so if the radius is congruent, that means that the circles are congruent. So this I'll call circle C, and this I will call circle B. So I would say circle C is congruent to circle B, and that's because circle C has a radius of 5, and circle C and B both have a radius of 5. Points that are in the interior are a shorter distance away than the radius, and points that are on the exterior have a longer distance away than the radius. So I showed you that in green and orange. So you can see that the orange point is on the interior, again, because it is a shorter distance away from the center, whereas the green point is on the exterior because it is a longer distance away to the center of the circle. And then a point is on the circle if the distance is equal to the radius. So we know that that blue point right there is on the circle, this blue point is on the circle, because it is 5, we'll call it inches, 5 centimeters, whatever, away from the center. So because it's equal to the radius, we know that it's on the circle. Now we're going to go into some definitions. Again, you guys can pause this if you need to. So the distance from the center of a circle to a chord, the distance from the center of the circle, picture that's this O, to a chord is the measure of the perpendicular segment from the center to the chord. So if I asked you guys, first of all, let's talk about what a chord is, right? So a chord, where did my chord go? Why did my chord not go here? So let's talk about what a chord is. So a chord, essentially is, if you have a circle like this, a chord is where the two endpoints are anywhere on the circle. So for example, here and here, if I was to connect those, that makes a chord. Okay, again, I can make another chord here to here. Both of those points are on the circle, so we refer to that as a chord. Now the longest chord that we have goes through the center of the circle, and that is called the diameter. So the diameter is a chord. So that is the diameter, and it also is considered a chord. It is the longest chord because as you start to go down again, the chord becomes shorter and shorter. Okay, so if you picture that, drawing all these chords, and again, they could go in any direction. So this is also a chord as long as the endpoints are on the circle, but the diameter is the longest chord. Okay, so going back to this, so the distance from the center of the circle to a chord is the measure of the perpendicular segment. It's the measure of this right here, the perpendicular segment from the center, okay, here's the center, to the chord. Okay, so, and again, we're going to be we are going to be working with this, no worries yet, okay? I'll put some numbers in a second, but again, over here at this picture, if you have a chord, I'll say chord AB. If I said, how far apart, or how far is C to chord AB? If I asked you that, if I said, how far is C to AB? You wouldn't draw this line, okay? That's too long. You're going to draw this straight down, and it hits it at a perpendicular, and that represents the distance from C to AB. Theorem 74. So if a radius is perpendicular to a chord, then it bisects the chord. So if you know that CD is perpendicular to AB, okay, if you know this to be true, so if they give this to you, if you can prove right angles, yada yada, then you know for sure that CD is bisecting AB. In other words, this piece has to be equal to this piece. So if you see a perpendicular, just like you do right here, if you see this, you automatically know that this piece on the right is congruent to that piece on the left, if it's perpendicular. The converse is also true. So if you know that this piece is equal to this piece, then you know that it was perpendicular. Okay, so if those pieces are congruent, then you know that it's perpendicular. Okay, the perpendicular bisector of a chord passes through the center of the circle. Okay, the perpendicular bisector of a chord passes through the center of the circle. So if you guys see here, I have this orange line drawn right here, okay? And it's showing you that it was perpendicular and it is congruent, so bisecting. So it's bisecting and it's perpendicular. Therefore, it has to hit the center of the circle. So the same thing, I want you guys to take a look at, so this picture, the green with the blue, because this is misleading as well. So again, the perpendicular bisector of a chord. So is this blue piece perpendicular to the green? Yes. Is it bisecting the green? Yes. That means that it will eventually pass through the center of the circle. Now, of course, this is my drawing, so it doesn't look like it, but I promise it will pass through the center of the circle if you were to extend it. If it is a perpendicular bisector, it will pass through the center of the circle, okay? So let's go ahead and let's put some of what we learned to the test here. So we are given a circle, and it says that PR is perpendicular to ST. So immediately I'm pulling some information out. So I know that if PR is perpendicular to ST, immediately, okay, so PR is perpendicular to ST. We can go back to our theorem. What do we know if it's perpendicular? Right here. If it's perpendicular, then it bisects the chord, okay? And so if this is notice that it goes through the center of the circle. So because this goes through the center of the circle, it's technically considered a radius. And so if it's perpendicular, then it bisects the chord. So I'm going to mark that up immediately. So let's go ahead and start writing our proof of what we're putting and filling out. So we have circle Q. That tells us that Q is the center of the circle. We also have PR is perpendicular to ST, and that is given. So again, we are going to, our next step is that SR is congruent to RT. And the reason that SR is congruent to RT is because if a radius is perpendicular to a chord, if a radius is perpendicular to a chord, then it bisects the chord, okay? And again, we know that this is a radius because it passes through the center of the circle. So it's a part of the radius. The radius is contained in there, okay? So here we go. My next step, so I'm looking at this and I'm trying to prove that PS is congruent to PT, and I feel like you guys are going to want to go to congruent triangles because you don't remember the equidistance theorem. So we're gonna go to congruent triangles. Okay. So you can prove if you wanted to right now that PR is the perpendicular bisector of ST, and then if a point like P is on the perpendicular bisector, then it's equidistant away from the endpoints of a segment. You can go that way if you remember this. If not, and I don't feel like you guys remember this, we're gonna go to congruent triangles. So we are going to say angle PRS is congruent. So this is a side. PRS is congruent to angle PRT. And we are going to say that it's because they are both right angles. So right angles have to be congruent to each other. We are also going to say that PR on the top triangle has to be congruent to PR on the bottom triangle, and that is any segment is congruent to itself. That's the reflexive property. And therefore, because we have a side and an angle and a side, we can say that triangle PSR is congruent to triangle. So look at all of triangle PSR is congruent to all of triangle PTR, and that is by side, angle, side in steps 2, 3, and 4. And then lastly, I can say that PS is congruent to PT, because if triangles are congruent, then their parts have to be congruent. So if triangles are congruent, then their parts have to be congruent. Okay, and again, there's a multitude of ways you guys can do this. This is just one example. Okay, we're gonna do some more work. So ignore that. The radius of a circle O is 13. Okay, so that's important. The radius of circle O is 13. I'm just gonna draw a radius right now and mark that as 13. The length of the chord is 10. So PQ right here represents 10. Find the distance from chord PQ to the center O. So they want me to find this distance. And again, when we are looking for distance, right here, we know that it's going to be the perpendicular. Okay, so like we automatically know that. That's going to be perpendicular right there. Now, if you see my radius of 13, I want you to picture swinging this radius around. So this is also 13, this is also 13. I can draw as many radii as I want. The one that I'm interested in drawing is one that connects points that we have. So this radius is 13, and we also know that this radius over here is 13. And we know that if our radius hits a chord at a perpendicular, that it bisects the chord. So this 10 is no longer 10, it is going to be 5 and 5. And so then we have a triangle, and you can use Pythagorean's theorem, but this is just a 5, 12, 13. And so we can say that the distance, this green segment, is 12. Okay, so going from this point, and you can add points if you want to. I think the book calls this point R. So you can say that OR is 12, but the distance from chord PQ to center O is 12, okay? And again, I understand that this is a lot of information, and again, flashcards help a lot. Going through this video helps a lot multiple times to get you used to, you know, what chords are and all that good stuff.